Good evening, guys. Welcome to our class for today. This is My Science Tutors Online, and I remain Otobo Michael, your online physics tutor. And for today, we are going to be looking at half-life and decay constant. Half-life and decay constant. In our previous class, we discussed areas related to radioactivity and the properties of radioactive particles. Now, one of the properties of radioactive particles is that when they disintegrate, they also disintegrate into half of their original amount. And that is what we want to look at today in our class. So please get your writing materials ready, because we'll be doing a very few discussion and then we'll be solving a lot of problems. So if you have your calculators ready and your biro and your writing material ready, we'll go straight to the class without wasting much time. But before we go, please, if you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. Invite your friends to come and enjoy what we are enjoying. Then also give us a thumbs up, give us a like, give us a positive comment so that you continue to encourage us. Okay, so if you are ready, we are also ready. Let's go straight to the class for today. So as I said, we are looking at half-life. Please try to minimize distraction. Try to minimize distraction so that you can understand this topic very well. Okay, so let's go to our class for today. So as I said, we are looking at half-life. So experiments have shown that when a radioactive substance decay, they have a definite rate of decay. You understand? When radioactive substances disintegrate, they disintegrate at a definite rate. So half-life, simply put, is the time taken for half of an element initially present, or the time taken for the radioactive substance to decay to half of its original amount. Okay, so the time taken for a radioactive substance to decay or disintegrate to half of its original amount is what is known as half-life. So what is here is the half-life of a radioactive element is the time taken for half of the atoms initially present in the element to decay. Alright, so that is what experiments have shown. Experiments have shown that all radioactive substances, they have a definite rate of decay. Okay, so what the statement simply means is that if the half-life of an element is given as t years, okay, so it means that at t years, 1 gram of that element will decay to half of its mass. So what's that simply mean? If you have 1 gram of an element and the half-life of that element is t years, it means that after t years, which is the first half-life, half of that element will have decayed and half of it will be remaining, because half plus half is equals to 1. Okay, half plus half is equals to 1. So half of the element will have decayed and half of it will be remaining. That is for the first half-life, which is t years. Now for the second t years, for the second half-life, or for 2 half-life, the number of years you will now multiply the number of years by 2, because this time it is the second half-life, so it's going to be that t times 2. So that is 2 half-life. Now at 2 half-life, at 2 half-life, the number of this element that will remain will be equals to 1 over 4. At first half-life, let me just although that is what I've written here already, you can see it here, but let me just say that at first half-life t years, the number of the elements that will decay will be half of it. Decay, I'll use d here. Then the number of elements that will remain will be 1 over 2. I'll put arrow there to tell you that this is to remain, d is decay, and arrow is remain. Okay, so this is for the first half-life, or 1 half-life. 1 half-life. Now for the second half-life, which is 2t, what I said now, 2t, okay, which is 2t, for the second half-life, which is 2t, the amount of substance that will have decayed will be half of what was remaining before. That is 1 over 2 of 1 over 2. Why what will remain will be 1 over 4 is what will remain. Now, if I want to find if this is the time, if this is the total time it takes for this substance to decay. Okay, so if the substance has 2 half-life, let me just say if the number of half-life for this particular element is 2 half-life, that is, this substance has 2 half-lives. Now the number of elements, or the number or the quantity of the particle that will have decayed at 2 half-life will be equals to 1 over 2 of 1 over 2 is 1 over 4, right? So this gives me 1 over 4. Let me just okay, so let me just clean that part so that I move it forward. So what will remain, what will decay? This is 1 over 4. Okay, then what will remain is 1 over 4. Alright, but when you want to do this calculation, this is for the second half-life. What has decayed is 1 over 4 of the substance that was remaining. It's 1 over 4. What is remaining is 1 over 4. Now for you to calculate the amount that has decayed at second half-life, you have to add this to this, so that you have 1 over 4 plus 1 over 2. So at 2 half-life, the amount of substance decay will be equal. If you add this together, you are going to have 3 over 4. So, and the amount that is remaining, this amount decayed, then amount remaining is 1 over 4. Okay, so at 2 half-life, the amount of a substance that has decayed is 3 over 4 of that substance. So assuming we have n substance, n amount of a particular substance, 3n of the substance will have decayed, and then n over 4 of the substance will be remaining. I want you to please try and understand this. That's okay. At first half-life, you have n over 2 of the substance decayed and n over 2 of the substance remaining. Remember that in all radioactive equation, the amount that is decayed plus the amount that is remaining must be equal to your original amount. Okay, so here we have that 1 over 2 plus 1 over 2 is equals to 1. 3 over 4 plus n over plus 1 over 4 is also equals to 1. So the amount of substance that has decayed and remaining should be equal to the initial amount that you have. Is that okay? So all this one, you can also get this particular value of the amount of substance that has decayed from simply, if you have n substances, you will know that the amount remaining is equal to n over 4. So you see, this is the initial amount. So initial amount minus amount remaining will give you the amount that has decayed. So if you do this, you are going to have 3n over 4 as the amount that has decayed. This is simple equation. This is your LCM. Multiply this, you have 4n minus n all over 4. So 4n minus n is equal to 3n all over 4. So this will give you the amount that has decayed. Now the amount remaining is n over 4. So for second half-life, or for 2 half-life, 3 all over 4 of a substance will have decayed and n over 4 of a substance will remain. This is a constant and this must remain. Is that okay? This is a constant and it remains. This fraction does not change. So please take note that this fraction does not change. At first half-life, the number of a substance that has decayed is 1 over 2 and the amount that will remain will be 1 over 2. At 2 half-life, the number that will have decayed is 3 all over 4 and the number that will remain is n over 4. Now, this is what I have summarized here. First half-life is this, and I've said that the amount remaining will be n over 2 and the amount that has, of the particle that has decayed is n minus n over 2, just like I did here. So this is for first half-life. Then the second one is for 2 half-life. The amount that is remaining is n over 4. The amount that will decay is equals to n minus n over 4 is equal, gives us 3n over 4. That's what we did here. Now for the 3 half-life, the amount that is remaining of every substance that decay is n over 8 particles remain, while n minus n over 8 will have decayed. So you have that at 3 half-life, 7n all over 8 of a particle will have decayed. Then at 4 half-life, the amount of substance that will remain will be n over 16, and what has decayed is n minus n over 16, which is 15n over 16. So at 4 half-life, the amount of substance that will have decayed is equal to 15 all over 16. Is that okay? While the amount that will remain will be n over 16. N represents the initial amount of the substance. Please don't forget. Then at 5 half-life, the amount of the substance that will have decayed is equals to the remaining is n over 32, and the amount that will have decayed is equals to n minus n over 32. That gives you 31 all over 32. So these figures that you are seeing here, they are not, I didn't just bring them from the moon. That's okay. They are standard. These fractions are standard, and you should know how we got them. That is why I had to put all these equations by the side, so that you know how I got all these fractions. That's okay. Because if you are writing JAM, it is good you know these short formulas, these short methods, so that when you want to solve any problem on half-life, it becomes very easy for you. Is that okay? So this is what it all means. Now what I said was that I've said this before, that the fraction decayed is equal to original fraction minus fraction remaining, or original fraction is equals to fraction decayed plus fraction remaining. That's what I said before. That take note that the fraction decayed plus the fraction remaining must be equal to the original amount of the substance. So this is what you should take note of. Okay, so if you can take note of this, life will be easy for you, and then you will find out that calculations in half-life, they are very simple. But I know that many students actually find this calculation a little bit confusing and twisty. That's why I'm taking my time to explain this part of this class to you, so that when I will start to solve the problems, it will become a little bit easy for you to flow along and then understand. So okay, so I hope this is clear, and then we are going to solve some problems to drive on what I have discussed so far. Alright, but before we solve the problems, I'll give you a table where I have tried to summarize this information that I have here, and I will encourage you to just copy that table and put it in your notes, so that you can always refer to it. Okay, if you are given a question and they say, oh, at 3 half-life, what amount of a substance will have decayed? You should know that at 3 half-life, the amount of substance that will have decayed is 7 times the initial amount of substance all over 8. Then the amount that will remain will just be n over 8 of that substance. Finish. If they say at 4 half-life, what amount of substance will be have decayed? Is 15 over 16 of that amount of the substance that will be have decayed. Then n over 16 will remain. Simple. So this is what I've summarized on the table. What I've summarized in the table, they are not like that in any textbook. I try to bring them up together and then put them as a summary. It's just for your own consumption and for understanding. If they are scattered in different textbooks, I have to bring them together. Well, is that okay? So that is exactly how it is. Now this is an example just to at least throw more light on what I've said. Now this is an example, right? Say if we have 1000 atoms of a radioactive element initially present, whose half-life is 10 years. The amount of the substance lost after 3 years will be what? What they are asking is that after 3 years, what amount of the substance will have decayed? After 3 years, after 3 half-life, what amount of the substance will have decayed? That is what they are asking you. Okay, so let me just break it down again for you to see yeah, I have to break it down again. That one, we have been told that the half-life of the substance is 10 years. So for the first 10 years, the amount of the substance that will remain will be n over 2, which is 1000 over 2, which is equal to 500, isn't it? Now the amount that has decayed will be original amount minus amount remaining, is it not? So that is 1000 over 500, which is 500 atoms. This is for the first year. I have to bring it down this way. Now for the second half-life, which is 2 of this half-life of this amount, which is 2 times t, or 2 times t, or 20 years, the amount of the substance that will remain is n over 4, remember, which is 1000 over 4, which is 250. Now the amount decayed will be equal to original amount minus remaining amount, which is 1000 minus 50, which is 750 for the second half-life. Is that okay? Now if you remember, we said that for the second half-life, the amount that has decayed is 3n all over 4. So if instead of you to go through this lengthy process, you can just say, okay, amount that has decayed at second half-life is equal to 3n over 4, which is 3 times 1000 over 4. If you multiply that, you are going to have 750, and you see that these two, they are the same. Okay, I hope you understand this. Now at the 3 half-life, which is 3 times t, 3 times t is 30 years, so which means at 30 years, the amount of the substance that will remain is n over 8. Go to that table and see it, which is 1000 over 8. That gives you 125 atoms. Now decayed amount is equals to 1000 minus 125. That gives you 875 atoms, right? Now we also said that you can use this short formula that at 3 half-life, the amount that has decayed is equals to 7n over 8. Or you can say at 3 half-life, the amount that has decayed is equals to n minus the amount that is the fraction that is remaining, which is n over 8. Okay, so this initial, so if you work this out, you are going to have 7n all over 8. So 7 n over 8, 7 times n, which is 7 times 1000 over 8, and that gives you 875 atoms. The same thing will have here. I hope you can see that. So if you are able to understand this short formula I brought up, it will make life easy for you. So at 3 half-life, the amount of the substance that will be lost is equal to 875 atoms. See it? That is how these formulas are applied, and as we do more problems, you will understand better. Okay, so let's go further. Okay, so as I said, this is the table that I tried to bring up, and you have to, it's a summary of all that I've said before. So please copy this table into your notes. At first half-life, amount decayed is n over 2, amount remaining is n over 2. At 2 half-life, amount decayed is 3n over 4, or 1 over 2 of n over 2. So you still have added this plus this to give me this. Is that okay? So this gives me n over 4 amount remaining. Then at 3 half-life, amount decayed is 7n over 8, or 1 over 2 of n over 4. Don't forget that the amount decayed at any of the half-life is, the total amount decay is, for you have to add this plus this plus this, it will give you the same amount that is here. So if I add n over 2 plus this, 1 over 2 of n over 2 is 1 over n over 4, this is n over 8. So if I add n over 2 plus n over 4 plus n over 8, it will give me 7n over 8. Okay, so I try to bring this table up so that, so for 3 half-life, you have 15n over 16 decayed and n over 16 remaining. Okay, so at 5 half-life, the same thing, just up till you get to maybe 8 half-life. Okay, so it depends on the question that is given to you. You can always refer to this table to solve your problem. All right, so also I try to also bring this out that if t is your half-life and the time of decay is given to you and you know the number of half-life, you can actually use this equation to get your time of decay, or you can also use to get your half-life. Okay, so time of decay is, that is the duration of the decay, or time of decay. Can be a second, can be in days, can be in years. All right, so that is the duration of the decay. Then the half-life, if it's given to you and you know the time of decay, you can find maybe number of half-life, and as the case may be, this equation we shall apply it when we solve some problems. Okay, so this is about half-life, and let's go further to discuss other areas of half-life and then decay constants. Okay, so we are looking at, this is decay constant. Okay, so decay constant is defined as the instantaneous rate of decay per unit atom of a substance, or decay constant is the number of atoms disintegrating per second all over number of atoms in the source at that particular time. Now, from experiment, it was discovered that the rate of decay is proportional to the number of atoms of the material that is present. Okay, and that is what they use this this is a differentiation equation to solve, and then we arrive at this taking logarithm of both sides, and then they arrive at this particular equation, and this is the equation for decay constants, because all that is solved there is for them to arrive at this particular equation. Lambda here is your decay constant. So decay constant is equal to 0.693 all over time. So this is your decay equation. So from this you can actually find the time of decay if you know the decay constant. Okay, so this is all about decay, and then the curve that is on your right is a decay curve. Okay, this is a decay curve. Okay, so guys, this topic does not require too much talking. It is when we solve problems that you really get a better grasp and understanding of what that we'll be discussing since. Alright, so we are going to solve some problem now so that we can get a better understanding. So this is a sample question, and this question says that a certain radioactive element has a half-life of 10 years. Okay, then the question is how long will it take to lose 7/8 of its atoms originally present? So what this question is telling you is what is time of decay. Then how long will it take until 1/4 of the atoms originally present remains unchanged? Okay, so here, for you to solve this problem, you just you are given half-life of this radioactive element T. You are giving the half-life to be equals to 10 years, right? So it's given to you to be 10 years. Then the fraction that is decayed is given to you to be equals to 7/8. This is the fraction that has decayed. Alright, so so this is how you are going to solve this problem. If you go to the table, right, you will get the fraction decayed, or the time that it will take for it to decay to 7 and 8, you will get it. But we can also solve it this way, right? You say that one half-life, so I will write that like that, one half-life, that is T1, which is 10 years, at one half-life, which is 10 years, which 10 years, amount decayed, as we said before, is 1/2 of the substance. This amount decayed, and amount remaining is what? 1/2 will be remaining. Okay, then at two half-life, another 10 years, or you can say 2T, which is 20 years. Okay, because you have to add these two together to get the number of years. At two half-life, the amount of substance that has decayed, as we said before, is what? 3/4 of the substance decayed, and 1/4 of the substance will be remaining. We know how we got this one. The initial amount minus what is remaining, which is this 1/4, will give you 3/4, right? So fine. So then at three half-life, which is another 10 years, the amount of the substance that will remain is 1/8 that will remain, and the amount that has decayed will be 7/8. So if you look at this method, you see that 10 plus 10 plus 10 is equals to what? 30 years. So it means that if you take 30 years for this substance to decay to 7/8 of its original fraction. So this is the solution that you are looking for. Is that okay? Now, I can also solve the same problem by saying that half-life is equals to time of decay all over number of half-life. Okay, so if I can remember the table, we will see that for this substance to decay up to 7/8, it will take what? How many half-life? This 1, 2, 3. It will take 3 half-life. And we are given that half-life is equals to 10. So yeah, I will put 10 Don't forget that n is equals to number of half-life. This is number of half-life. Okay, so half-life is 10 is equals to time of decay all over 3. So the time of decay is equals to 3 times 10, and that gives me 30 years, because here time of decay is given to us in years. Okay, so that gives me 30 years. So which one suits you? Whichever of this method that suits you, you can use them to solve the problem that you want to solve. Alright, so you can either use this. If you prefer the long method, you can use this. You can also use, but it depends on your understanding. If this is what you understand, please use this. If you understand this, use it. Okay, so that is question number 1. Then question number 2 says that how long will it take until 1/4 of the atom already present remains unchanged? Now look at it from what we have done here. Now from what we did here, we say that at 2 half-life 1/4 of the substance will remain, isn't it? So you are not going to anywhere again. And so at 2 half-life 1/4 of the substance will remain. So 2 half-life is equals to, since half-life is equals to 10, 2 half-life is equals to 2 times 10. So the number of time that, or the number of years it take will be 2 times 10, which equals to 20 years. 20 years. See? So for 1/4 of the substance to remain, it will take 20 years. That is 2 half-life. 10 plus 10 is 20. Okay? Then if you want to use this method too, you can still use it. Right? So half-life is equals to 10. Then the time of decay is what you are looking for here. Then number of decay is equals to 2, or number of half-life is 2. So T is equals to 2 times 10, which is equals to 20 years. As I said before, please use the method that suits you. Okay, so any of this method that suits you, please use them. I don't have to, for this particular question, I don't have to go back to start to write all this again. Okay, because I've done them in the first part of the question. That's why I didn't go back to write on this one. No, I just picked it from the second line, because on the second line you see that 1/4 of the substance remain, while 3/4 of the substance has decayed. In the first line, 1/2 decay, 1/2 remain. In the third line, which is 3 half-life, 7/8 decay, and 1/8 remain. Okay, so please have this at the back. You see that questions in half-life, they are very simple. Let's go to another one. Fine, so this is another question. See, the half-life of a radioactive element is 4 seconds. If there are 20,000 atoms initially present, calculate the decay constant, the number of atoms remaining after 8 seconds, and the fraction of the atom that decayed after 8 seconds. Alright, so this is a very interesting question, and we want you to also pay attention very, very attentively. Okay, so decay constant from the equation we are given. In this particular question, you are given time and quantity of substance, and we said that decay constant is equals to what? We said decay constant from the equation we saw is equals to 0.693 all over T. So T is given to you to be 4 seconds. So if you substitute into this equation, you're going to have 0.693 all over 4. Okay, so if you do that, you have 0.173 seconds. 0.173 seconds. Okay, so that is for this number 1. That is for number 1, decay constant. So very easy, just for you to know how to apply the equation. Okay, so if it is time you are calculating, just for you to make time the subject of the formula. Now for the second one, second part, the number of particles that are in the atom initially is 20,000, right? There are 20,000 atoms that are present. So they said the number of atoms remaining after 8 seconds. Now, the half-life of this element is 4 seconds. So we can write that at first one half-life, which is 4 seconds, one half-life which is 4 seconds, time for half-life, the time for the decay. So one half-life, okay, I can put it as half-life, one half-life, which is 4 seconds. The amount decayed is 1/4 of the, 1/2, sorry. It's 1/2. As amount decayed is 1/2. 1/2 decay of the substance, and amount remaining is 1/2 of the substance amount remaining. Then two half-life, which is 2 times t, which is 8 seconds. Amount that remaining will be equal to 3/4 with decay, and 1/4 will remain. So what is the question? This question is that the number of atoms remaining after 8 seconds. Now this is your 8 seconds. So which means after 8 seconds, 1/4 of this n will remain, or n/4 will remain, or 1/4 of the substance will remain. So what you need to do is just say 1/4 of this, which is times 20,000, will remain, because that is what the question demands. So when you do that, you are going to have 1/4 of this is equals to what? 5,000 atoms. So you have that 5,000 atoms will remain. Okay, 5,000 atoms is what will remain. Then the next question, so this is question number 2. Now for question number 3, it said what fraction of the atom that decayed after 8 seconds. So I've said that fraction of the atom that decays is 3/4 of the element that will have decayed. So you do just 3/4 times what you have, 3/4 times 20,000. So if you work this out, you are going to have 5,000 times 3, because this will give you 5,000, right? Sorry, that's 5,000. Let's 4 divide this. So times 3 is equals to 15,000. So 15,000 atoms will have decayed, okay, after 8 seconds. So 8 seconds is at 2 half-life. Alright, so like what I said before, the amount decayed at a particular half-life, the amount decayed plus the amount remaining must be equal to the original amount. So if you add 15,000 to 5 times equals to 20,000. Okay, 15,000 to 5 times is equal to 20,000. It will have also been possible for you to solve this second part of the equation by saying that, okay, if 5,000 of the element of the atom is remaining after 8 seconds, then the amount that will have decayed will be 20,000 minus, okay, the amount remaining will have been 20,000 minus 5,000. So this will give you the amount that has decayed, and that will be 15,000. See, so actually questions in half-life, they are not really that difficult. All right, so I hope this is clear. All right, so this is another question. In 24 days, a radioactive isotope decreases in mass from 64 grams to 2 grams. what is the half-life of the radioactive material. So in this particular one, you are not given the half-life. You are asked to find the half-life. Okay, so but you know that a substance will decay in indefinite stages. Okay, so which is now at every half-life the substance will decay until it gets to 2 gram, and we are told that the time of decay is 24 days. Okay, so what we need to do at first half-life, one half-life, the substance will decay from 64 all over 2 to 32 gram. That is one half-life. At second half-life, the substance will decay from 32 all over 2 to give us, I hope you are seeing it, so it will decay 32 divided by 2, that gives us 16 gram. At 3 half-life, the substance will decay from 16 to 16 all over 2. All over 2 to be what? 8 gram. At 4 half-life, it will decay from 8 all over 8 gram to 8 all over 2, which is equals to 4 gram. At 5 half-life, to be 4 gram divided by 2 to be equals to 2 gram. So you see that it's going to take 5 half-life for this substance to decay towards to 2 gram. Have you seen it? It will take 5 half-life for this substance to decay to 2 gram. Now remember we said that half-life is equals to time of decay all over number of half-life. So which means here T, the time of decay is given to us to be 24 days. So 24 days divided by 5, which is the number of half-life, will give us what? 4.8 days. So it's going to take this substance 4.8 days to decay to 2 gram. Okay, so this is the time, or this is the half-life of the substance. The half-life of the substance is 4.8 days. So if you multiply 4.8 times 5, you are going to have 24 days. Alright, you're going to have 24 days. Or you can actually still solve this problem if you see that one half-life is equals to T. 5 half-life will be equals to 5 times T, right? Equals to 5 times T based on what we have gotten. Now we have gotten that from what we have done here. We said that 5T, that is 5 half-life of 5T, is equals to the decay duration, which is equals to 24. So if you find T, which is your half-life, will be equals to 24 all over 5. Okay, 24 all over 5. So if you solve that out, you still have your 4.8 days. So please, whatever method that suits you, you can use to solve for half-life. Alright guys, so thank you. We are going to another question. I think I have some more questions, maybe 1 or 2 more. So before I will leave this particular section. Okay, so this one says that the half-life of a radioactive material is 6 hours. What quantity of 1 kg of the material would decay in 24 hours? So this is not different from what we have solved before. So what you just need to do, since the half-life is 6 hours, you are going to find the quantity that will decay in 24 hours, isn't it? So one half-life is 6 hours. Okay, 6 hours. So I'm going to write just 6 so that I will not bore myself. Just take note that the 6 days 9 hours. Okay, so 6 hours, one half-life, 1/2 of the substance will decay. Remember, and 1/2 of the substance will remain. Remember, I hope you remember. Okay, so 1/2 kg will remain and 1/2 kg will decay. Then the second half-life, which is another 6 hours or 12 hours, 3/4 will decay, or 3/4 kg will decay of the substance and 1/4 kg will remain. Remember, at 3 half-life, which is 3 times 6, that's 18 hours, 7/4 of, 7/8 of the substance will decay, and 1/8 will remain. Remember, fine. At 4 half-life, which is the 24 hours, 15/16 will decay and 1/16 will remain. So at 24 hours, the amount of the substance that would decay is equals to 15/16 kg, or at 4 half-life, the amount of substance that will have decayed will be the original amount, which is 1 kg minus 1/16, which is the amount that is remaining. Okay, 1/16 will remain. So if you solve it out, you are going to have 16 minus 1/16, and that gives you 15/16 kg. Okay, but if actually you really understand that table, it will be easy. So it is good you begin to understand this arrangement and all these things that are in that table that I showed you initially. So please, I said copy that table. That table is just like a lifeline for any calculation in half-life. You can see how I've applied them. So you can actually go back and apply them to solve any problem on half-life. Is that okay? Thank you so much. So I think I still have one more problem to solve. Okay, so I still have one more problem to solve. This one's that a radioactive sample initially contains n atoms. After 3 half-life, the number of atoms that have disintegrated will be what? Okay, so they are saying that after 3 half-life, the number of substance that will have decayed will be what? Okay, so if you remember, you can actually just, if you are in JAM examination and you remember what we have discussed before, this one you will not even need to waste your time. Is that okay? You will not need to waste your time, because for me, I know that after 3 half-life, from what we have discussed so far, after 3 half-life, 7n/8 will have decayed or disintegrated, and 1/8 or n/8 will remain. So my answer is 7/8n. This is a JAM question, not WAEC, and it's an objective question. So at 3 half-life, this is what will have decayed. I will not need to solve anything. Okay, I will not need to solve anything. But if I need to solve, I will say that at one half-life, at one half-life, n over 2 of the substance will decay and n over 2 of the substance will remain. So that's what we have been discussing thus far. Then at 2 half-life, I'm just doing all this for you to understand. At 2 half-life, you have 3n all over 4 of the substance will decay, while n over 4 of the substance will remain. Go to that table and you see exactly what I'm doing here. There are 3 half-life, which is what this question says. 7n all over 8 of the substance will have decayed, and n all over 8 of the substance will remain. If I go further, at 4 half-life, I will have that 15n all over 16 of the substance will have decayed, and n all over 16 of the substance will remain. So that's how it goes. That's how it goes. So this is what you need for this particular question. Okay, so thank you guys. I hope I've dealt with this topic very well for you, and any question you see in Half-life will not be difficult for you to solve. Right? So on that note, I want you to solve these questions. Please just go through them and then you solve them. Send your answer to me through the WhatsApp number that will be showing on your screen. I want to see. I want to know see those people who understood this question very well and how to solve this topic very well and how to apply it to solve problems. Okay, so this is where we are drawing the curtain on this particular topic. Thank you so much, and I appreciate you for your time. All right, it's been a little bit lengthy, but it is worth the while. So thanks a lot. If you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. Give us a like, give us a thumbs up, give us positive comments, share our videos with your friends, invite your friends, and advertise the video for us. Reach us through the WhatsApp number that is showing right on your screen. We are here to help you in physics and make you a better student in physics. So thanks, we appreciate you for your time. We hope to see you in our next class. Thank you.